The first thing, exam is basically on percent, fractions, and decimals. I'm going to give you a couple of examples how to solve in changing a percent to a fraction and to a decimal. All right. So now the first one we have is 12%. Of course, a percent is over 100. So that means we can write that percent as 12 over 100. But then we have to look to simplify this fraction. So the simplified fraction, and I'm going to just rewrite it, I can divide both of these by 2. I can divide the numerator and the denominator by 2. So that's going to give me 6 over 50. I can also divide this again by 2 as well. So I can divide both the numerator and the denominator divided by 2. Because we want to simplify that fraction. So if I divide both the numerator and the denominator by 2, I'm going to have 3/25. There isn't any other value I can divide both the numerator and the denominator by. So this is my final fraction. 3/25. That's the simplified fraction. And of course, if we're changing this decimal, if we're changing this percent to a decimal, we just move the decimal point 2 places. So here I'm going to write 12, and I'm moving the decimal point 2 places to the left. 1, 2. So that means that's going to equal 0 and 12 hundredths as a decimal. All right. Let's look at the following. We have 15%. We need to change 15% to a fraction. And when we look at a percent is basically the value of the percent over 100. So that's 15 over 100. So now we have to look to simplify this fraction. 15 and 100 are both multiples of 5. So I can divide both of these values by 5. So I'm going to rewrite this as an equivalent fraction. Whatever I divide my numerator by, I have to divide my denominator by. So that's 5 here in my numerator, and divide 5 in my denominator. Of course, 15 divided by 5 gives us 3. And 100 divided by 5 gives us 20. And there is no other factor that relates 3 and 20. So that means 3/20 is my final answer. Similar here, we move the decimal point 2 places to the left to change this percent to a decimal. So here I have 15. If the decimal is out of sight, it is to the right. So the decimal is here, and we move it 2 places to the left. 1, 2. So that means this is going to equal 0 and 15 hundredths. Okay? Now, if we look at this percent here, this one is going to be greater than 100, but still a percent is always over 100. So we'll write that as 350 over 100. Okay? So now, we need to simplify this fraction. I can divide both of these by 10. I can divide both the numerator and the denominator by 10. That's going to give me 35 here. And then that's going to give me 10 here. Alright. I can further divide this by 10. I can further divide this by 10. Alright, so if I divide this by 10, this is going to give me a decimal number, which is 3 5/10. And 10 divided by 10 is going to equal 1. Well, anytime we have a fraction with the denominator of 1, we can write that as a whole number. Here, this is going to be a decimal number. So that's going to be 3 5/10. This is the fraction form after it was simplified. So even though it's a decimal now, we wrote it as a fraction, then we simplified it. So this is also counts as the fraction form. Now, similar to this here, if we move the decimal point 2 places to the left, that's going to have 350. Move the decimal point 2 places. And that similarly, just like this one, is going to equal 3 5/10 or 50 hundredths. So both of these are the same. They're just, this one just has the place value in the hundredths. Oh, sorry. This one has the place value in the hundredths. This one stops at the tenths place. All right. So of course, 3%. We have to change this fraction, change this percent to a fraction. So we have 3 hundredths. There isn't a factor that we can divide both 3 and 100 by, so that means this fraction is 3 hundredths. Okay? Similar to this one, when we rewrite this percent as a decimal, so we have 3. We have to move the decimal point 2 places to the left. 1, 2, add a placeholder 0, and then that is going to equal 3, 0, and 3. 0 and 3 hundredths. Alright. Alright, so does anyone have any questions at this time? Nope. Alright, so now we're going to look at two models. Alright, thank you. So now we're going to look at two models. We're going to look at two, I forgot to put this. Let's put this right here. Alright. So we're going to look at two models. For this model, for these two models, we're going to be asked the percent. We're going to be asked the percent. Now make sure you pay very close attention, because this isn't out of 100. So we first have to find the total amount. So we have 5, 10, 15, 20. So 20 represents our total. And the amount that is shaded represents our part. So that's 5, 10, 14. So that's 14 20ths. Now we have to look to simplify. We can do this one of two ways, and I'm going to show you both ways. So we can find the percent, because we know part over total equals percent over 100. Okay? And I'm just going to put the percent here. Alright. So now we can look to find a common factor that we can multiply times 20 to get to 100. If we multiply 20 times 5, that's going to equal 100. 20 times 5 equals 100. Similarly, whatever we do to the denominator, we do to the numerator. Of course, we multiply times 5. And I'm going to write that out here. 14 times 5. 4 times 5 is 20. Drop your 0. Raise your 2. 5 times 1 plus 2 is 7. So that means our percent missing here is 70. So the model represented here equals 70%. Also, if there was not a relationship between these two, and we're given the part and the total, we can divide. So that will be top value inside, bottom value outside. I'm very quickly going to work this out. So of course we can't divide here. We cannot divide here, so put zeros in the quotient. Add a decimal point, raise it up, and add another 0. We can divide 140 into groups of 20 7 times. So that'll be 7 times 20, and we're subtracting 140 minus 140. And that's 0. So that gives us 7/10, or 0 and 70 hundredths. And of course, if we're changing a decimal to a percent, move the decimal point 2 places. So I'm going to rewrite this here. And that equals 70%. All right. So that's how you would solve this type of problem when given a model. Make sure you count the total, which is going to be your denominator. Make sure you count the amount shaded, that's going to be your numerator. And if there is no relationship, make sure you divide top value inside, bottom value outside. Okay? All right, let's look at this model here. If we're asked to find the percent, we have to look at first the total amount. So we have 1, starting from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and the 1 whole represents 10. So that'll be 10 as our denominator. And we also have to look and determine where this point is. So that's 1, 2, 3, 4, 5, 6. So that's 6/10. We can use our proportional equation. Part over total equals percent over 100. Of course, we can multiply 10 times 10 to get 100, and whatever we do to the denominators here, we do to the numerators. And of course, 10 times 6 equals 60. So this model represents 60%. All right. Are there any questions at this time? If so, unmute yourself. If not, I'm going to assume that we don't have any questions. 5, 4, 3. All right, so we can move on. Here we go. This is the last thing that is on the test. Representing the different types of fraction as division. So here, we're going to represent these 3 division as fractions. So we're going to show the different ways we can represent these 3 problems. Okay? So of course, if we wanted to use the division house, well, we have top in, bottom out. Remember, your numerator is always going to be your dividend. So that's 14. Your denominator is always going to be your divisor. So that's 15. And if we wanted to use the division symbol, that would be 14 divided by 15. It's almost as if you're swinging the 15 here and writing the division symbol like this. All right, so remember, 14 divided by 15. All right, so these are the 3 ways that we can write this problem. 14 divided by 15, 14 divided by 15, and 14 divided by 15. Okay? For 9 divided by 20, if I wanted to show this as a fraction, I'll similarly, like I did here, swing the divisor, and then that's my fraction. So I'm going to rewrite my fraction here. 9 divided by 20. And if I wanted to use the division house, top value inside, bottom value outside. So all three of these represent the same division problem. 9 divided by 20, 9 divided by 20, and 9 divided by 20. All right? All right, so the last one here. If I wanted to rewrite this as a fraction, I would have top value inside. That's 12. Bottom value outside. Oh, that's not 12. So that's 5. So that's 12 divided by 5, 12 divided by 5. Similarly, if I wanted to use the division symbol, that's going to be 12, our numerator, divided by 5. And all of these represent the same division problem. 12 divided by 5, 12 divided by 5, and 12 divided by 5. All right? So everything I just went over is going to be on your exam.